Table computers are becoming more and more feasible to integrate into our everyday lives. With the advancement and high adoption rate of mobile touchscreen technologies, digital enhancement of the traditional table seems like the next logical step. A table computer can allow for several things that cannot be afforded by a traditional desktop computer. For one, the traditional desktop computer does not allow for multiple simultaneous users, which can make collaboration difficult. Furthermore, multi-touch technology can allow for natural and intuitive ways to interact with technology, and the large screen size of a table computer can allow for a better defined sense of space. The table computer can, of course, also improve on the traditional wooden table. The ability to access all of one's digital media is no doubt the biggest advantage in today's technology-driven society. Additionally, the ability to escape space constraints of traditional media by hiding or shrinking items, and the ability to quickly and effortlessly make copies of an item, can be a huge asset. The main topic of my research was object duplication. In its most basic form, object duplication is the simple matter of taking one object and creating a second identical object. This technique, however, can still be a hindrance to collaboration, as changes made to one object would not affect any copies of said object. With that in mind, I set out to create a system which could perform a shallow copy of objects, so that changes made to one instance of the object affect all copies of that same object. Now we will see a demonstration of the system I created for this project. The system was created using Java, along with the processing framework, and used the 2EO protocol to get input from the table. As you can see, objects on the table can be moved intuitively using the touchscreen interface. Objects can be scaled using 2 fingers, and rotated. Placing one hand on the object and sliding a finger or fingers off of the object with the other creates a copy. There are 3 modes available for each object, which can easily be cycled by pressing a button in the menu bar. Point mode is an easy, non-persistent way to point something out to others. When an object is in point mode and you touch it with one finger, or stylus, it draws a cursor on each other copy of the object to show where you're pointing. Annotate mode allows you to actually draw on the object and offers a more persistent method of highlighting. And finally, move mode simply allows you to move the object around using one finger. We will now see another example to better demonstrate the system's functionality. To start, I will make duplicates of all 3 objects and shuffle them around the table to make things interesting. You may have noticed that the different objects have different border colors, and this is used as an easy way to differentiate what's a copy of what. I will then set the annotation color of all copies along the bottom to red, and all those along the top to blue. As you can see, as I write hello in red, this same message appears in that object's copy in the top right corner. Similarly, if I walk around the table and type in the word world in blue, that message appears back in the copy in the bottom left. This back and forth process can be continued with all copies and played with to make some bad drawings. Once the system was in place, I got some people to come in and try the system as a very informal study. In this video clip, you can see them getting acquainted with the system by experimenting with moving, rotating, scaling, and duplicating objects. Once everyone had some time to play with the system, I got them to perform some simple tasks. While some of these tasks may not be practical, they can demonstrate how the table can be used in a collaborative manner. In the first task, I got participants to collaboratively find Waldo, and then point him out to other members of the group. As you can see, they have given each other copies of the image to facilitate finding Waldo. Once he is found, he is circled on the image, and others can clearly see him. This process is repeated a second time with another image. Again, notice how they give each other copies of the image to facilitate this task. The next task involved 2 connect-the-dot pictures. Users created copies of these images and got one partner to work forward while the other worked backward, to complete the task faster than a single person could have. The third task was more practical. Users were tasked with sketching out a simple user interface that included a title bar, a menu bar, tabs, and a few other simple features. While the group on the left took this task lightly, you can see that the group on the right creates a copy of their canvas and collaborates in creating a user interface in an efficient manner. The final task was designed to be a reading and annotation task of the text document. In this video clip, you can see users underlining, highlighting, and generally marking up the page. The main issue encountered with this test was that the size and resolution of the screen made it difficult to read the text without interfering with other people's space, but overall allowed participants to easily show others what they thought could be improved in the text. In the end, all participants believed this type of system could be a real asset in collaboration, with some slight improvements and refinements to the software and the technology. Thank you.